Well, hello everyone. This is Mikhail Golovnya. I'm a senior advisory data scientist at Minitab. In this video, I would like to show you some of the basics how to use predictive analytics in Minitab Solution Center. So what I have here is a data set that I opened in the Solution Center. It's called Solar Power. So I used a very simple data connection by going here and uploading file from my local machine into the Solution Center. There's also other different ways you can do it. So what I will do, I'll just show some of the elements in this data set. What we have here is a set of annual records of power generation by a solar power plant on an hourly basis in kilowatts. So we have for different hours of the daytime, we have recorded sun elevation in the sky, in the degrees, also the direction of the sky in terms of north, south, etc. Temperature, precipitation, percentage of sky covered by clouds, humidity, wind speed, wind direction, barometric pressure, and generated output power on average during that hour. So what we want to do here, we want to build a predictive model that predicts power generation based on all of these inputs except for time. And again, we have pretty much an entire annual cycle of data here. To illustrate how to work with predictive analytics, what I'm going to do here, I'm going to go to Predictive Analytics Module. This is a continuous response variable, so we're dealing with regression. I will start by running CART Regression, which is always a useful way to look at things in a modern non-parametric predictive analytics form. So what we can do here, we can say, okay, we're going to predict power generation. And again, in predictive analytics, we want to predict something based on something else. So in this case, I'm predicting power generation based on all available continuous inputs, as well as one of the categorical inputs, wind direction. I'm going to use traditional validation using a test set. About a third of the records, 30%, will be set aside randomly for validation purposes. Then I will set up some basic options. We'll be optimizing least squared error, and I'm going to increase these some of the minimum numbers for CART trees to something like 130, so that this way we don't get too much the trees of a very large size. On the results side, I usually make most of these options available, and I also activate these additional tables. I increase these numbers to something that will cover the entire collection of the nodes that will be generated in a tree. That pretty much that simple. Then I click OK. I let the CART do all of its job, and then I can also turn off my data output window so I can get a little bit more space here. And as you can see, it generated 21 node CART tree. Here's the history in terms of test sample R squared. So as you can see, it can go all the way up to about 80%. The tree itself is pretty big, kind of difficult to work with, even though you can export it or increase the resolution and everything and just see what's happening. And again, as you can see, we're hitting about 80% R squared in the test sample. It shows what variables were primarily used and all these other diagnostics here. My advice to you, before we get bogged down in that tree, there is a very useful feature here that says select alternative tree. And by looking at the entire history of model building, we can pick something, let's say a 6-node tree here, create it. Notice if I turn on Navigator, I can switch back and forth. Like this is the original 21-node model. This is that alternative, simpler model that was extracted. So when I look at this model, as you can see, I'm located over here. So I lost some bits of accuracy. And my overall performance is now around 72% R squared. Those are the variables that are primarily used. But because the tree is small, now we can actually see what CART is doing here. Remember, this is modern tree-based non-parametric model. It's data-driven. There are no assumptions, no functional forms, nothing. It's kind of a divide and conquer strategy. And what CART shows here is that on average, I started with about 600 kilowatt average power generation for the entire annual cycle. And then what it shows here, if the sun elevation is above 26 degrees in the sky, which is way kind of into the day, then the power generation increases to about 1200 kilowatts. Otherwise, it drops to 230 kilowatts. Now, on this side, when sun is high, if there's also low cloud cover, less than 2/3 of the sky covered by clouds, the mean generation goes up to 1365 kilowatt. And if the sun direction is also happens to be in the southern portion of the sky, it goes all the way up to 1451 kilowatts. Otherwise, it drops to 882, or if there's a huge, like significant cloud cover, it drops to 753 kilowatts. On the other hand, if the sun is below 27 degrees in the sky, there's a further clarification. If it goes even lower in the sky, less than 14.5 degrees, power generation drops to only 86 kilowatts. Otherwise, it goes to 414. And again, the cloud cover defines whether the further generation increases or decreases. So again, it's a very simple example, but it's very easy to understand for most people. And you can easily generalize it to any type of industrial setting when you need to predict a certain output on a continuous scale. CART tree, while not necessarily giving you the best, most accurate prediction, it actually highlights some of the key things that are happening, and it's a useful thing to look at. There's also these additional tables at the bottom that are quite instructive. Like, for example, in this table, all of the terminal nodes are presented. There are 6 of them, along with the corresponding rules. And you can also see the predicted power generation, so you can come up with a very simple summary story of what's going on. This is a great way to look at different ways to understand what's going on, to get the general highlights, especially in those cases when you're not interested in the actual exact prediction, but you're more interested in finding certain rules. Like, for example, there could be rules that are associated with, say, an increased percentage of defects on a production line, or maybe you're studying the power output of a certain engine and you're looking at all the different inputs, control inputs, or other types of inputs, design characteristics. So it's a very useful tool to have a quick and dirty investigation and understanding of what's going on. So I highly recommend CART. I think this is a great starting point for modern predictive analytics, and Minitab Solution Center, as you can see, offers you a very easy way to upload the data set and jump directly into modern predictive analytics tools within this easy environment. Thank you very much. This is Mikhail Golovnya, Senior Advisory Data Scientist, Minitab.